Welcome to lesson 6.1, Slope-Intercept Form. Today we're going to talk about how to take those linear equations and write them in what we call slope-intercept form. You'll notice we have the words slope and intercept in our title of the word. It's because we're going to use slope and we're going to use intercept in our equation, so that way when you look at the equation and it's set up in this form, you will automatically know the slope and you will automatically know the y-intercept. All right, so we have this problem here with Andrew where he wants a smartphone that's $500. It's actually just going through and basically going over how we answer or how we graph our problems. So in this case, I'm just going to kind of quickly fly through it and remind you of a couple things. You have 500. That's going to be our y-intercept, okay, because that's how much he owes his parents. So when he's made 0 payments to pay them back, he still owes them $500. So in this case, the y-intercept is 500, right? So we know that that is where we plot our point on our graph. And then we also know that he's paying back $50 per month. Since he's paying back the $50, it's going to be a negative 50 for our slope because he's getting rid of the money. So this graph is based on Andrew's point of view. Now there's two things I want to talk about here. So here, B, we are talking about the slope. And here we know that the slope is negative and it's going to be a line because it's a constant rate of change. He's continuously giving $50 every 1 month. That isn't changing, right? And then here we have our y-intercept. What our y-intercept means in the real-world situation is it's our initial rate. So it's kind of like a starting line. Now, that's only the case when it comes to real-world situations. Okay? If there isn't a real-world situation, the y-intercept may not be the starting point for the graph. All right? But in this case, because it is a real-world situation, the y-intercept is your initial rate, your starting point. All right? So here we have our starting point of 0, 500, and we know that the change in y is going down 50 for every 1x, so our slope is negative 50. So what I'm going to do is I've plotted my points, and I'm going to count 50 units down, and then 1 unit to the right. Now notice here, this is 50 units, so it's not that we're counting 50. 50 is how much each box is worth, so when I count down, what is 1 box, that's actually 50 units, and then over 1, which is 1 month, I can plot my point, and so on and so forth. Okay, and then now I've got all my points plotted. I'm going to actually, since this is a continuous graph, I'm going to draw my line all the way through because he could pay partial sums back throughout the months. However, it's a line segment because he isn't starting with any more debt and he isn't going to pay them back more than he owes them. Right? And then from this graph, we can see that it'll take him 10 months. So by the time we get to 10 months, he gets to $0 that he owes his parents. So from the graph, we can determine at any given point in time how much money he still owes his parents based on the month. Okay, so let's take this one step further. So we have, when we're looking at problem B, so I'm skipping the part of the notes where it's the explain 1 and example 1. I'm actually just going to jump us right to actually doing it and going to example B. Right? So we know that our line passes through the points 0, 5 and 2, 13. Since it passes through those points, we're going to be able to find the slope. So you know when you're given 2 points that you can find the slope by using your m is equal to y2 minus y1 over x2 minus x1. In this case, I'm going to use my second point and my first point. So my second point is going to have the 2, and my first point is going to be my y-intercept. All right, so in this case, I have my y2, which is 13, minus my y1, which is 5, minus my x2, which is 2, minus my x1, which is 0. 13 minus 5 is 8. 2 minus 0 is 2. And I know that this gives me a slope of 4. Right? So my slope in this case is 4. And then now, so I'm going to substitute the slope and the x and y coordinates of either of the points in the equation y equals mx plus b. So now this is where we have to look at what each part of the slope-intercept form means. So here, I'm just writing it down here. You don't want to write in your turn area. Your y is always your output, which we've already learned. Your x is always your input. M, we've talked about this before, it's your slope. So you already know that your slope goes right here next to your x. And B is always your y-intercept. So now we're getting really picky with our variables. These are the variables that you have to use when we're talking about slope-intercept form. Right? So in this case, we're going to substitute 4 for m. And then because I was given my y-intercept up here, I know that my y-intercept, so when x is 0, my y is 5. So I'm going to substitute 5 for b. Okay, so then my equation of my line would be y is equal to 4 times x plus 5. So now, say that I wasn't given the 0, 5. Let's say I was given something else, and I had to use the point 2, 3. I can use the point 2, 3. I have to remember that I can plug in all of my variables. So in this case, I would know that my m is 4 because I found it. So 4 would go here. And then I know that my x would be 2 because it tells me. So 2 would go here. And then I know that my y would be 13 because it tells me. And then now I can just work my way backwards and solve to give b by itself. And I would do 4 times 2 is 8. 13 would remain the same. And then I would have to subtract 8 from both sides. And I would get 5 is equal to b. Okay? So again, I can use other points. If I know my slope and I have a point, I can find my slope-intercept form. So if you look at this your turn problem right here, and I'm going to erase all that I put down here, but you do want that, so make sure you have it in the margin somewhere. So here I have the slope of -1, and that's my point. So I need to write it in slope-intercept form, but in this case, I have the slope, but I need the y-intercept. So since I don't have the y-intercept, I have to find that, then give my answer. Here I have 2 points. Neither of them is the y-intercept, so I have to find my slope, and I have to find my y-intercept, and then I can give my answer. Okay? As always, make sure that you're showing your work, taking your time, writing down questions that you have, and finish it. Go all the way through and finish so we can go over your answers. All right, so then, again, we are going to move on to, instead of going through the example that's already done for us, we're looking at graphing from slope-intercept form. So what we're going to do is we're going to take example B, and example B is an equation that's in standard form. And we're going to take that equation that's in standard form, and we're going to solve it for y, so that way we can turn it into slope-intercept form. So whenever you're given standard form, it can be changed to slope-intercept form. And what you're doing is you're just solving for y. So here, I want to subtract 2x from both sides. Okay, because I want to get the y all by itself. And then because I want so when you look at slope-intercept form, this part is always in front. So instead of having, and we like to have it as an addition problem because that kind of helps us determine the y-intercept. Now it can be a subtraction problem, but we'll talk a little bit more about that in class, but why it helps right now to have it as an addition problem. Right, so I know that minus a positive is the same thing as plus a negative, and that will allow me to switch my numbers around with the commutative property. And then I have to divide both sides by 6. And so I get negative 1/3 for my slope. And 6 divided by 6 is 1. So now I know, because this is my m, so I know my slope is negative 1/3. And I know my y-intercept is 1. And it's a positive 1 because it's a plus positive 1. Okay, so I know that when x is 0, y is equal to 1. And that's all I need. All I need is 1 point to be able to plot all my other ones, because I have a slope of negative 1/3. So that means, so it's rise over run. So if it's a negative, I either have to put it with the rise or with the run. And in this case, I'm first going to put it with the rise. So I'm going to go down 1 because it's negative. But then I have to go to the right 3, because if I do the negative on the top, then I have to do the positive on the bottom. Now let's do it the opposite. So then my positive is my 1, so I go up 1, and then to the left 3, because the 3 would be negative. Okay, and that works because of the fact that we have a negative slope. Now, if your slope ended up going this way, this is a positive slope, and you know that your slope was negative. So if you ended up with this line here, you know your answer is incorrect because of the fact that it ended up being a positive slope. So always double check yourself. Right? So again, we graphed the point 0, 1. We moved 1 unit down and 3 units to the right. And then we can also move 1 unit, and I would write this down, up, and 3 units left. Now, you guys have had a lot of practice, so you should be able to solve these equations for y. It's exactly the same thing as we had been doing before, so don't let the fact that we're changing it to slope-intercept form get you caught up. All right, so then explain 3. Determine solutions of equations in 2 variables. Okay, so what we're going to do, so what we're looking at here is if we're given a real-world linear situation described by a table, a graph, or a verbal description, we can write an equation in slope-intercept form, and we can use that equation to solve problems. Okay, so basically what we're saying here is if we're given the formula, if we're given a word problem, we can create the formula, create a graph, and solve problems with those formulas and graphs. So we're going to take a look at B right off the bat. And we're talking about a chairlift that descends, so you know it's going to be a negative slope because it's going down from a mountaintop to pick up skiers at the bottom. The height in feet of the chairlift is a linear function of the time in minutes since it begins descending as shown in the graph. Find the height of the chairlift 2 minutes after it begins descending. Okay, so we're not told the y-intercept, we're not told the slope, but we do want to figure out, after it's been dropping down for 2 minutes, where is it? All right, so let's take a look at how the slope-intercept form and all this can help us. So I know that the graph contains the points 0, 5,400, that's our y-intercept, and I can also see right here very clearly that it goes through the point 4, 2,400. So I can use those 2 points to help me find my slope. Yeah, I don't want to use any other points because of the fact that they're not directly on 2 lines, so it'd be hard to really guess what numbers those were. So here my y2 is going to be 2,400 because it's showing me that I use this as y1. And so my x2 is 4. And so when I do that, I get a slope of negative 750 over 1. Okay, so I'm not going to do all the math in this case. When you simplify it, you end up with a slope of negative 750. All right, and then it represents the rate at which the chairlift descends, and we know that it's descending because of the fact that it's negative. And then since the graph passes through the point 0, 5,400, we know that the y-intercept is 5,400, and that represents the height of the chairlift at 0 minutes. Okay, so we're going to let x be the time in minutes after the chairlift begins to descend. Y is the height of the chairlift in feet. So in our equation here, so our height is equal to a descending rate of 750 times however many minutes we descend for, plus 5,400. Okay, so now I was able to put together my slope-intercept form based on my information. And now I know that y, so I want to find, because now it says I want to find the height, so I'm looking for y, is equal to negative 750 is my slope. That doesn't change. But I know that I'm looking for how high it is in 2 minutes. So I'm going to plug in 2 for x, since x represents my time. And here I get negative 1,500. So that actually tells me, since this tells me, the slope tells me it goes down 750 feet in 1 minute. So then I know that in 2 minutes, it'll have gone down 1,500 feet. And if I'm descending 1,500 feet from the 5,400, that puts me at a height of 3,900. So now I know on my graph the point 2, 3,900 is a point, or is a solution to my graph. So here I know that this point is 2 and then 3,900. Okay, and more importantly, I know that after 2 minutes, the chair has descended to 3,900 feet. Okay. All right, so you have a couple of your term problems that are in there, and I do want you to give the elaborate problems a shot. Again, this is just a brief overview of what we'll be working on in class, so stick with it, get through it. I know it's going to be a little bit tough because we're taking this real world stuff and applying it right off the bat, but trust me, it will get easier as we continue to practice with it. Just don't forget everything we talked about in Module 5 because they work together hand in hand. Right? So as always, if you have any questions, be sure to email me or write them down so we can go over them in class.